This video is going to show you how to do goal 6 continued. If you felt comfortable after the first video, you don't have to continue with this. You can leave this page blank. But this would be more reinforcement, and if you are still confused, this would be a good one to listen to. So to figure this out, notice how this is arranged. You've got your potential, kinetic, and total energies listed in a row, and then we've got you solving for velocity. In this case, we're giving you heights for each of the locations of the roller coaster. So if we take our mass of 50 kilograms, which is at the top of the hill, and it's at a height of 4 meters, then we can solve for potential energy. First thing, because that's m times g times h. So a mass of 50 times a g of 10 times a height of 4 turns out to be 5 times 4 is 20 plus 2 zeros. We have 2,000 joules of potential energy at the top. We can assume that the speed of the object at the top is 0 because it's at rest before it starts to move. So that tells us kinetic energy, which is 1/2 mv squared. We can think of the v as 0. Our kinetic energy is going to be 0. Therefore, the total energy is just add up those two. 2,000 plus 0 gives us a total energy of 2,000. From there, you should be able to realize, hey, total energy at position 2, at position 3, at position 4 is always the same because it's going to be conserved. So I'm going to put 2,000 joules of energy for each of those total energies. The next thing I can realize is I know at position 2, I can solve it exactly the same way I did earlier. If I know the potential energy is, now it's only 3 meters tall, then my m times my g times my h. My mass is 50, my g is 10, but my height is now only 3 meters. So my potential energy here at position 2, 5 times 3 is 15, plus 2 zeros, gives me 1,500 joules of potential energy. If PE plus KE equals TE, then this KE must be 500. So when these are added together, I get 2,000. My potential energy at position 3 is going to be easy because down here, height is 0. So my potential energy has to be 0 also because of the m times g times h. H is 0 is going to give me 0. So my potential energy is 0 here. So that tells me kinetic energy must be 2,000. At position 4, they're going to ask me to figure out my height. So what I'm going to do there is I'm going to be able to first figure out, they give me V. So now I can solve for KE. KE is 1/2 mv squared. So 1/2 times my mass of 50 times my v of 6, which is square that. So 1/2 times 50 is 25. So 25 times 6 times 6, or times 36, is 900. So my kinetic energy at that point would be 900 joules. So I'm going to put 900 there. So then from my total energy equation, because I know KE plus PE has to equal TE, I can just take my TE of 2,000 and subtract my KE to figure out what my PE must be. So 2,000 minus 900 is 1,100. Now I'm going to be able to solve for H. And in both of these cases, 2, 3, and 4, I'm going to have to do the backwards solving because if my potential energy, PE equals m times, oops, you can't see that, m times g times h. If I know my potential energy is 1,100, my m is still 50, g is still 10, I should be able to solve for h. So 1,100 equals 500 h, so I'm going to divide both sides by 500. So 1,100 is going to be a decimal. 1,100 divided by 500 turns out to be 2.2 is my height. Height equals 2.2 meters. So that is what I put in the blank down here. So how am I going to solve for V? Same indirect or backwards method. I'm going to be, now I know KE, 500 and 2000. I know M, I'm going to solve for V. So in the case of number 2, my KE is 500 equals 1/2. My mass is 50, and I'm going to solve for V. So this is going to take a little bit of algebra. 500 equals 1/2 times 50, which is 25. Divide both sides by 25. So 25 goes into 50 2 times. Add the 0. 20 should equal V squared. Take the square root of both sides. So 20 second function square root of that, take the square root of it, and then I can go 20, and I get 4.47. So V equals 4.5 meters per second. So that's going to be my velocity when I have a kinetic energy of 500, 4.5. Here, my kinetic energy is 2,000, so I've got to do the same old math, but I'm going to do 2,000 is my kinetic energy equals 1/2 times M times V squared. So 25 V squared equals 2,000. 2,000 divided by 25 equals 80. Second function square root of 80 turns out to be 8.9. So V equals 8.9 meters per second. So that's how I can indirectly map out and find velocities if I know the kinetic energy, height if I know the potential energy. Finally, the last thing I want you to do is the little bar graph relationship. So this is hopefully helping you see how the energy changes from point to point. So if I look at the energies, at the top, number 1, position number 1 is right here. So at the top, position 1 here, I have 2,000 joules of potential energy. So I'm going to make my bar up to 2,000. Kinetic, I have 0. Total, I have 2,000. Position 2 is right up here at the top of the loop. So position 2, I have 1,500 potential energy. Kinetic energy, I only have 500, but total should be 2,000. So this total energy bar always stays at 2,000. I can draw that in everywhere. Total energy should not change. So the bar goes up to 2,000 each time, but what does change is my potential and my kinetic. Position 3, right here, is at the top, is at the bottom of the loop, right here. So at that point, I have 0 potential. All of the energy must be kinetic. 0 potential, all kinetic, 2,000. And the last place is at position 4, when I've gone up this little hill, where I have potential energy of 1,100, so a little bit over the 1,000 line, and kinetic energy is 900, so a little bit below the 1,000 line. Together, those should equal, if I stacked them up, they should equal 2,000.